Welcome back. In the last video, we looked at the linear pair postulate that says two angles that are a linear pair will add up to 180. And we looked at vertical angles that says vertical angles are always congruent or have the same measure. Okay, so let's look at how we can do that in some actual problems that involve some algebra. For example, A and B are vertical angles. The measure of angle A is 3x minus 7, and the measure of angle B is 2x plus 20. What is the measure of each angle? Okay, so as soon as I see this first sentence, angle A and angle B are vertical angles, I'm going to use my vertical angle postulate to say I know that the measure of angle A is going to equal the measure of angle B. Okay, that's using my vertical angle postulate. Okay, then the next thing I'm going to do is I'm going to keep reading, and it says the measure of angle A is 3x minus 7. Well, I know 3x minus 7 is the measure of angle A, so I'm going to plug it in for the measure of angle A. Then when I look at the next line, it says the measure of angle B equals 2x plus 20. So the measure of angle B I can substitute with 2x plus 20. So then to finish off this equation, I'm just going to put my equals. And now all I have to do is solve that to get my answer. So when I go to solve that, the first thing I want to do is get all my x's on the same side. So I'm going to subtract the smaller x. I'm going to end up with 3x minus 2x is 1x minus 7 equals 0 plus 20 is 20. Okay, then I'm going to add 7 to both sides. X plus 0 is x, and 20 plus 7 is 27. Okay, then it says what is the measure of each angle? So what I need to do is I need to plug that 27 in for A, and I need to plug that 27 in for B, and they should, 27, and they should come out equal, right? Because we said that they're vertical angles, and my vertical angle postulate says they're equal. So angle A is 3 times 27 minus 7. So let's see, what is 3 times 27? 3 times 27 is 81 minus 7 is 74. So that's angle A. The measure of angle A equals 74. So then I need the measure of angle B, which is 2x plus 20. So for B, 2x plus 20, 2 times 27 plus 20. 2 times 27 is 54 plus 20. So the measure of angle B is also 74. Thank goodness, because that means that I must have gotten the right answer for x. The measure of each angle is 74 degrees and 74 degrees. They are both the same because they are vertical. Okay? The next question says, what are the other two angles in the intersection for the problem above? Well, I usually draw a picture. For some reason, it just didn't even dawn on me to draw a picture. So what are they talking about, the other two angles above? If they're vertical angles, remember, that means they are across from each other when two lines intersect. So if those two angles are both 74, it wants to know what are the other two angles in the problem above. So this angle and this angle. So now we're going to have to use our linear pair postulate to figure out what those two angles are, right? So I can say that I know these two angles together should make 180. So if I do 180 minus the 74, that will give me the angle that I'm missing. So 180 minus 74 is 106 degrees. So that means this angle is 106 degrees and this angle is 106 degrees. So what are the other two angles in the intersection? They are both 106 degrees. Okay. Now the next thing we need to review from middle school, because it's been a while since we've talked about it, is the word perpendicular. Okay? Perpendicular are lines that intersect at a 90-degree angle, or lines that intersect at a right angle. Okay? All four angles at an intersection that are at a perpendicular intersection will hit each other at 90 degrees. Okay? So if you have perpendicular lines, all four intersections, if these two lines were perpendicular, instead of being 74 and 106, it would be 90, 90, 90, and 90 if I had perpendicular lines. Okay? The symbol that represents perpendicular is an upside down capital T. So just like we use symbol equals, we have a symbol for congruent, we have a symbol for not equals, we also have a symbol for perpendicular. Okay? So if I look at this figure, notice it says draw the following: line AB and line CD intersect at point E, and then it says line AB, and there is that upside down T. Anytime you see that upside down T, you need to think perpendicular, which means you need to think a 90-degree intersection. Okay, so line AB needs to be perpendicular to line CD. Okay, so let's see if we can draw that. I'm going to draw two lines that are perpendicular, which means they hit each other at a 90-degree angle, kind of like an XY axis. So there's one, there's another. One is going to be line AB, which means it needs to have a point A somewhere on it, and it needs to have a point B. I can put that point B here, I can put it here, I can put it here, I can put it anywhere along the line. The only place I can't put it is at the intersection, because I know the two lines have to intersect at point E, so that's going to have to be point E, right? So B, again, I could put B here, I could put B down here, anywhere along this line that already has the A on it, so I have line AB. I'm just going to put it down here. Okay, and then same thing, my other line needs to have a C and a D on it. I can put my 2 points anywhere along the line. So I could put C here and I could put D right next to it, or I could put D way over here, as long as C and D are on the same line. They intersect at point E, so this right here is point E. Okay, now I have not drawn perpendicular lines yet. The reason I have not drawn perpendicular lines is because there's nothing in the picture that tells me I have 90-degree angles. So I need to have some sort of notation in my figure that says, hey, these really are 90 degrees. Okay, so what I do for that is, and you've seen it before, I put in one of the corners, you don't have to put it in all of them, you put the little red box, and that indicates it's 90 degrees. If you don't see that box there, and they haven't told you in the prompt that you should be doing perpendicular, then you can never assume you have 90-degree angles. No matter what your picture looks like, no matter how close to 90 it looks, you can't ever make that assumption. Okay? All right, the next thing it says, find x in the figure above, so the one we just drew, so that the measure of angle AEC equals 9x plus 18. Well, what I want to do is I want to figure out, well, where is angle AEC? So let's see. AEC. So AEC is a whole corner. Well, we just said that these are all 90 degrees. So this corner, that is 9x plus 18, is really 90 degrees. So I know that my 9x plus 18 is going to equal 90 degrees. Okay? So the first thing I need to do to solve this is just take away 18. And I'm going to get 9x equals 90 minus 18, 72. Divide that by 9. And I get 1x equals 8. Okay? All right, so in this lesson, we talked about how to apply some algebra to working with vertical angles and linear pairs. And then we also reviewed what perpendicular lines are. And then we may never have seen this before. We learned the symbol that means perpendicular. Okay, in the next video, we're going to see how to apply these to a proof. All right, thank you so much. See you in the next video.